Thank you very much indeed for those very kind words. It really is an extraordinary honour and very humbling to be standing here today to give the biennial Leeuwenhoek lecture. Many thanks indeed to the Royal Society and to the award committee for the privilege and the opportunity to talk today about rabies. Rabies is one of the most horrifying and deadliest diseases that we have in the world. It's a disease that has disappeared off the public health radar in many prosperous nations, but it continues to exert a very heavy toll in the poorest communities of the world. So in this talk, I'll be exploring the prospects for rabies elimination globally and asking if we can consign rabies to the history books. But I first wanted to start with some introductory remarks about rabies. Rabies is caused by viruses in the genus Lysovirus, and you can see these bullet-shaped virus particles here in the slide. The disease is an acute progressive encephalomyelitis, and by that we mean a disease of the brain and the nervous system. It's a fatal disease. Once signs of the disease appear in humans or animals, death is virtually always the outcome. And it has the highest case fatality of any disease. All mammals can be affected by rabies, but the vast majority of human deaths, more than 99% of cases around the world, are caused by transmission from domestic dogs. And there's a very long association between people, domestic dogs and rabies, and rabies is a very ancient disease as a result of that. In fact, ever since there's been writing, people have been writing about rabies. The first record appeared more than 4,000 years ago in the laws of Ashana, and one of these laws explicitly deals with the subject of mad dogs and prescribes what the owner of a rabid dog must pay in compensation. And the link between human rabies and the bite of a mad dog has also been long understood, as shown in this image here. The fatal and incurable nature of the disease has also long been recognised, leading to numerous superstitions and remedies. And Pliny the Elder described in great detail one of his cures, which was to insert the ash from the hair of the tail of the rabid dog that had inflicted the bite into the wound of the bite victim. And that expression still lives on today in hair of the dog, which is an equally dubious hangover remedy. So, although rabies is fatal once the disease appears, not every bite of a rabid dog will result in rabies. It depends partly on where on the body a person is bitten, but also on the progression of the virus to the central nervous system. And in the first stages of infection after a bite, the virus remains for some period at the site of inoculation. And it is this point that the virus is vulnerable to attack by the immune system. But a critical point in the infection cycle is uptake into the peripheral nerves. At this point, the virus is then protected from the nervous system, the immune system, and essentially the die is cast. Medical interventions cannot now change the outcome. And the virus hijacks the cellular transport machinery in the nervous system to move quite rapidly towards the central nervous system, where there then is a phase of massive replication. And it is at this stage that signs of the disease usually start to appear, and this is equivalent to the incubation period, which is typically around a month, but can actually last several months and even years. Once in the central nervous system, that's when clinical signs appear, and the virus is then spread to other parts of the body through the nervous system, but most importantly to the salivary glands, because it's from the saliva that it can then be transmitted, usually through the bite of a biting animal. And during this period, the animal is infectious, and death will almost invariably follow within a few days. So the clinical signs of rabies are actually quite similar in people and in animals and associated with neuronal dysfunction. But it's always a harrowing and traumatic disease for the patient, for families, and for healthcare workers. Change of behaviour is particularly striking, and changes of behaviour in people can be really distressing. People go through periods of intense fear and anxiety interspersed with periods of complete lucidity. And I remember one harrowing interview with the mother of a child who had died from rabies and describing this in horrible detail. Hydrophobia and aerophobia are also distinctive signs, but only in people. They don't occur in animals. In aerophobia, even the slightest draft here in this image a paediatrician in South Africa breathing very gently over the skin of a rabies patient, which elicits a very sharp inspiratory spasm, a gasping, fearful response as the patient is terrified by this interaction. With hydrophobia, it occurs when a patient tries to sip or drink water in the early stages, and that can progress to actually a fear of even the sight of water. And in managing the disease, the best that can be done is sedation and palliative care to manage the symptoms. But in resource-poor settings, even these drugs are not always available. And to this day, we still sometimes hear reports of rabies patients being locked into rooms, left alone, to die in isolation, sometimes tied to beds because of their severe agitation and aggression. But the good news is that rabies is 100% vaccine preventable. And the foundations for prevention strategies lay in the discoveries of Antony van Leeuwenhoek. He, together with Robert Hooke, is often considered to be the father of microbiology. He was a draper, but he had an extraordinary talent for grinding lenses. And he constructed very simple microscopes, but they could magnify more than 200 times. He described in intricate detail the world of microorganisms. He was a very talented microscoper. He had insatiable curiosity and a real eye for detail. And he looked at samples from water taken from the sea, canal, snow water, for example, and even from his own and other people's mouth scrapings. And it must have been absolutely extraordinary to be the first person to see this new microcosm. And he obviously relished describing the details of what he saw. He wrote numerous letters to the Royal Society, which were translated and published in the Philosophical Transactions. And here, just one of those papers published in 1677, where he describes, I'm not sure if you can read that text, but he was describing the animalcules, the little animals. When these did move, they put forth two little horns. The place between these two horns was flat, although the rest of the body was roundish, sharpening a little towards the end where they had a tail, near 4 times the length of the body, of the thickness, by my microscope, of a spider's web. And not only these descriptions, but those measurements subsequently proved to be extremely accurate. Although I must say I'm quite relieved that here the title of the paper, and contemporary journal articles fortunately have somewhat snappier titles than those published in 1677, and I haven't got time to read it all out this evening. But although Leeuwenhoek was the first person to see bacteria, the implications of his findings for disease were not fully realized until 150 years later, when Pasteur provided the scientific proof for germ theory and refuted the theory of spontaneous generation. Pasteur made many major breakthroughs in many areas of science, and he was also a pivotal figure in rabies research. He was the first to develop a rabies vaccine based on the principles of what we call post-exposure prophylaxis, vaccinating people after they've been bitten by a dog. And he recognized the opportunity provided by that period immediately after the bite, before the virus gets to the brain, where it could be vulnerable to vaccination. And just as an aside, when I came here this afternoon, I have a guest room here in the Royal Society, and the Royal Society very thoughtfully had located me next to a painting of Pasteur with the rabbits, which he used for developing the vaccine. So I'm very grateful for that and felt quite at home. So Pasteur in 1885 gave his first vaccine to Joseph Meister, a boy who'd been severely bitten by a rabid dog. And the inoculations were successful and the boy survived. And the vaccine went on to be used very widely. And this strategy, this post-exposure vaccination strategy, it still forms the basis of one of the most important arms of prevention today when people are bitten. Of course, today, the vaccines are more highly purified. They're very safe. They're highly efficacious. But they're still in very high demand. 29 million people are treated each year when they've been bitten by suspected rabid dogs. And because the vaccine is such a high-quality vaccine, it's also very expensive. And this comes at a cost of about $1.7 billion per year. Rabies vaccine can also be given pre-exposure, and that's more akin to conventional vaccines, to people who are at high risk of exposure. There are also very high quality and safe vaccines for vaccination of animal reservoirs, injectable vaccines for domestic animals, and oral vaccines also available for some wildlife species. So with all these tools available at our disposal, where do we stand in terms of canine rabies? Well, canine rabies has been eliminated from several countries and regions, mostly the wealthier countries or island states. But the disease is still rampant across Africa and Asia. And while great progress has been made in Latin America, pockets of the disease still exist. And most of my research on rabies has been focusing on tackling the problem in Africa and Asia. But it seems like that my interest in rabies actually started from quite an early age. In fact, it was when I was sorting out some old storybooks from my childhood just a year or so ago that I picked up this book, and it fell open on the page of the story of Old Yeller. This is a story of a boy who adopts a dog that gets attacked by a rabid wolf. The dog develops rabies and subsequently had to be shot. It's quite a harrowing story for a child, and I do remember finding it perhaps both horrifying and fascinating in equal measure. But from a childhood surrounded by animals and with a lifelong interest in animals and wildlife, it was perhaps unsurprising that I ended up doing a degree in zoology at the University of Southampton and then a degree in veterinary medicine at the University of Cambridge. It was about a year after graduating from vet school that I had my first encounters with rabies, while based at the Institute of Zoology in London and working on the Serengeti Cheetah project. And I became involved in an outbreak of rabies in African wild dogs. This is a highly endangered wildlife species, and the population of wild dogs in Serengeti National Park became extinct in the early 1990s as a result of successive outbreaks of rabies. And as a result of these experiences, I not only became aware of the significance of rabies as a disease of conservation concern, but also that there were some major gaps in knowledge about our understanding of the disease in Africa. And so I set out at that point embarking upon a PhD to look at rabies in the Serengeti ecosystem. And at this point, I really do want to acknowledge some of the key collaborators who've been so instrumental in shaping my career and supporting my work. Throughout my career, I've had the great good fortune to work with excellent collaborators. While at the London School of Hygiene and Tropical Medicine, Chris Dye was my PhD supervisor, and I benefited enormously from his keen insights and understanding of infectious diseases. And while at Glasgow, I've worked with people who are not only outstanding scientists, but have been amazingly supportive. Dan Hayden, Katie Hampson, Tiziana Lembo. And I've also been lucky to have worked with some great PhD students. Tiziana was the first. Subsequently, have worked with Felix Lancaster and Magai Kare. And Magai was set to lead a really exciting program of rabies research in Africa, but was tragically killed in a road accident very early in his postdoctoral career, and we really miss him. But collaborative interdisciplinary teams like these are really critical when we're working on diseases such as rabies, which is a zoonosis. It can infect human and animals, and the problems span human and animal health. The approaches that we've taken in understanding rabies are also relevant to many diseases. And these include the zoonotic pathogens that are a cause of many of the emerging human disease problems of global concern today, for example, Ebola, SARS, avian influenza, but also many of the neglected diseases of poverty. And the challenges that we face in control of elimination of rabies typify some of the challenges in many of these other important disease problems. And in terms of neglected diseases, one of the most common of these is the problem of underreporting and lack of awareness about the scale and magnitude of the problem. And when I first started my career on rabies, this was absolutely the situation. Data from Africa, for example, came largely from case incidence data that were reported by countries to the World Health Organization and published in the annual World Survey of Rabies. And typically in Africa, around 200 human deaths were reported each year, which, set against the backdrop of the many health challenges on the continent, gives the impression of rabies as a largely insignificant problem. And people only care about things they know about and hear about, and generating the evidence to the true burden of rabies has been an important first step in raising the awareness needed for disease control. So there are several reasons why human rabies cases are underreported, but we had the idea to use case incidence data from clinics to construct probability tree models that could help us predict the likely number of human deaths. So this is using information on the incidence of disease, the site on the body where people are bitten, which is an important predictor of disease, and the proportion of people who actually receive post-exposure vaccination. And using these quite simple models, we came up with estimates that there were 100 times more human rabies deaths than officially reported in Tanzania. And this work was then taken on further, refined and developed by Katie Hampson, who came up with more country-specific estimates and came up with estimates of 37,000 deaths in Asia, 21,000 deaths in Africa, and around 180 deaths in Latin America. The highest number of cases is in India, with about 20,000 deaths, but the highest incidence, the per capita deaths, is highest in Africa. And to put this in context, this is around 59,000 people every year dying of dog-mediated rabies. As with all predictions, there is some uncertainty around these estimates, but we're very confident in saying tens of thousands of people die every year. And the sad reality is that the reason we don't hear about these deaths is because rabies is not affecting people who have influence. The people who die are those in the most impoverished communities in the world, most often in rural areas. And there are two reasons for this. It's in rural areas where we have the highest incidence of dog rabies. And these are the people who face the greatest challenges in accessing life-saving vaccine. And this is why rabies is a disease of poverty. If we look at access to life-saving human vaccine, in the richer countries shown here with high human development index, you're virtually certain of being able to get vaccine if you're bitten by a rabid dog. That's not the case in the poorer countries. And it's not just in terms of the national level. Within these countries, it's the poorest people who also are facing challenges in access to PEP. And this is demonstrated quite starkly with these data from Tanzania, where you see people who are living in more remote areas, further from clinics, in the top graph, and shown with the paler bars, and those of low socioeconomic status in the lower graph that are facing the delays in getting to clinics. And remember, these delays mean the possibility of death. That it threatens, any delay can be life-threatening because you've got that small window of opportunity after being bitten when vaccine is likely to be effective. And this problem is typified by the case history of this gentleman in Tanzania. And on his back and on his hands, you can see scars where he was bitten by his daughter when she developed rabies. He recognized the risk when his daughter was bitten. But as a subsistence farmer, it's difficult. He doesn't have ready cash at his disposal. Generating cash to meet the transport and the medical costs is difficult. He tried to get the owner of the dog to help cover the medical fees, but the owner denied all responsibility. He never did get his daughter to hospital, and she died a few weeks later. A second example is this family, again in the similar part of Tanzania, mother with her 6 children. She had recently acquired a puppy and developed rabies and licked or bit every one of her 6 children. She also recognized the urgency of the situation and the need to get her children to the clinic. But she could only afford treatment for 1 child. What an impossibly agonizing choice for any mother to have to make. And these are just 2 of the thousands of case histories that have now been compiled. So rabies isn't just about the deaths. Harrowing and distressing though these are, there's a huge underlying burden of psychological and economic trauma that affects those in the most disadvantaged communities. So in confronting the problems of rabies, I found that through a lot of my career, I've been faced with many perceptions and a very common narrative that have been hampering dog rabies control in Africa and Asia. Time and time again, we hear the same reasons for why it's impossible to control rabies in Africa and Asia. And these are just some of those common statements. rabies in wildlife makes it futile to control or impossible to eliminate rabies in dogs. There are just simply too many stray dogs in Africa and Asia. It'd be impossible to vaccinate enough dogs to control the disease, and it would be way too expensive to vaccinate enough dogs. And so much of my career has been about generating evidence to examine the validity of these perceptions. And I only have time briefly to summarize the findings here. But based in the Serengeti, a fairly obvious first place to start was around the question of wildlife and wildlife reservoirs. We know that rabies can infect all mammals, but we also know that only a few species can act as reservoirs. The concept of a disease reservoir is deceptively simple. We probably intuitively all know and what we understand by a reservoir, but it can be surprisingly challenged to identify reservoirs and to tease out the role of different host species. And this really matters because it determines where and how we can direct our control efforts. We only have to look at the challenges we face in tackling bovine tuberculosis in the UK to understand the difficulties around this. And in Africa, we have way more wildlife species, blessed with an abundance and diversity of wildlife, many of which can potentially be acting as reservoirs. So one of the first questions we are asking is whether rabies can cycle in wildlife in the Serengeti independently of dogs. And to tackle this in a complex environment such as Serengeti, we had to draw on multiple strands of evidence generated through interdisciplinary research. And we often liken this process to weaving a tapestry, where we're sort of drawing on different threads of evidence from which we hope to get glimpses of insight from which a picture will finally emerge. And this approach has allowed us to establish a framework not only for looking at rabies, but for other infection reservoirs. And in assembling the evidence, we drew on a number of different studies, broadly epidemiological approaches, genetic analyses, and intervention studies, and started off by looking at the spatial and temporal pattern of cases in dogs and wildlife, which I started with Chris Dye during my PhD and was picked up and developed further by Katie Hampson, who developed a contact tracing approach, which exploited the fact that rabies is very distinctive and well recognized. And when rabies occurs, you have a rabies incident, it's usually very memorable. So it's possible to go back into communities and very accurately trace rabies transmission chains and get the precise timing of rabies events when they occur. And when we look at the spatial pattern of cases, here is a map of the Serengeti. Domestic dogs are shown in red and wildlife in blue. And wildlife rabies does occur throughout the ecosystem. Here, this is the park shown clear, and the communities living around the park here in the grey areas. But although there are a lot of wildlife cases, transmission and incidence is dominated by domestic dogs. You do see, here in the blue, you do see short chains of transmission in a number of wildlife species, but these don't appear to be sustained. And genetic approaches, a very powerful tool that we have to infer relationships between viruses. And here, analysis of partial sequence data from viruses allows us to reconstruct relationships between viruses that indicate a pattern dominated by domestic dogs as the origins of transmission networks, and wildlife only coming at the end of these chains, similarly to livestock, which we know are dead-end hosts. So all of these different threads of evidence allow us to conclude initially that in terms of Serengeti, there's no evidence for independent wildlife cycles. And this series of photos, I think, illustrates quite nicely several important features of the disease. So the transmission directionality is from here, dogs, a rabid dog, to wildlife, the lion. It also exemplifies the abnormal behaviors that you see in rabies. It's not normal for a dog to go and attack a lion. You can see the lions looking quite bemused and startled by this. And it also shows that when we talk about aggression and bite, it's not just a kind of a dash in and nip behavior. This is a really aggressive, fierce, gripping, biting, holding behavior. These are serious injuries when a rabid animal attacks. And this dog has got hold of the muzzle of the lion and actually able to bring it down. Finally, the lion is able to free itself and runs off. But you can also see the giraffes here looking quite startled by this unusual occurrence. So when we're on our understanding of the situation in the Serengeti is that rabies is remained primarily in dog populations. There is some spillover to wildlife and some transmission among different wildlife species, with some spill back from wildlife to dogs. But the key issue is that the maintenance is primarily the domestic dogs. So if we can control rabies in dogs through mass vaccination, we should be able to disrupt transmission in the dog population and thereby prevent onward transmission to wildlife. These chains of transmission will then break down, and we should have a situation where we can eliminate rabies entirely. And so we went on to test this hypothesis through a large-scale intervention, and this involved vaccinating domestic dogs in villages surrounding the Serengeti National Park. We started with about 150 villages shown here in the blue dots, and with population growth and splitting of villages, there are now around 250 villages. And this allowed us not only to test the hypothesis about reservoirs, but also to generate valuable data to inform the design of vaccination strategies. And one of those questions is, what level of coverage do we need? How many dogs do we need to vaccinate? And this depends on the transmissibility of the virus. It's referred to as R0 by epidemiologists. And the more transmissible the virus, the higher the value of R0. And the higher the value of R0, the higher the proportion of the population that needs to be vaccinated to control the disease. And to achieve control, you need to bring the value of R0 down below 1. And when we look at values of R0 for several diseases, you can see rabies here at the bottom. The values are hovering close to 1, between 1 and 2, and much lower than other vaccine-preventable diseases, including those that we've already eradicated. The two diseases that we've eradicated are smallpox and rinderpest, with much higher values of R0. And we're making great progress with measles and polio, which is close to eradication, again with much higher values of R0. So these low values of R0 suggest that elimination of canine rabies through vaccination should be feasible. And we estimate that if vaccinations are carried out annually during campaigns, vaccination of 70% of dogs should prevent disease outbreaks. The other interesting feature about rabies transmission, these values of R0 are very consistent across a wide range of different settings, irrespective of dog density. These are just some examples. And the values fall between 1 and 2, regardless of whether they're urban or rural populations, Africa, Asia, Latin America, and irrespective of dog density. Just two examples: Bali, Indonesia, where there are more than 200 dogs per square kilometre, R0 is 1.2. In Serengeti, much lower densities, 1 to 10 dogs per square kilometre, R0 is 1.1 to 1.2. That means that a 70% vaccination coverage should be effective for controlling rabies in dog populations around the world, and that reducing densities, and this is an important additional corollary, is not an effective way to control rabies. But it is a way intuitively that many authorities do respond to rabies outbreaks, and particularly one of the common responses to this is indiscriminate culling. But indiscriminate culling is particularly ineffective, not only because reducing density is not the way to go in controlling rabies, but it has many other negative implications. Firstly, demand for dogs is high. People keep dogs because they want dogs. And when dogs are culled, they will be replaced quite rapidly, and this can actually lead to greater dispersal of disease. It can generate, as you might expect, animosity and bad will in the communities, and we know that community cooperation and engagement is a really critical factor underpinning success of vaccination programs and dog rabies control. And of course, it also has important animal welfare implications. Many of these programs are not very humane. In contrast, we know that dog vaccination is extremely effective, and that our theoretical predictions are strongly supported by empirical data. So 70% vaccination coverage during campaigns is sufficient to control outbreaks, as shown in this slide of data from Tanzania. Where you have 70% coverage, you don't see rabies outbreaks. Conversely, where the coverage is lower, you see larger outbreaks of rabies. It also turns out that 70% is the optimal economic scenario for what the WHO define as very cost-effective levels of investment for, in terms of public health. And where dog rabies has been controlled in the Serengeti, there also rabies in wildlife has also disappeared. And we've only had one case in the Serengeti National Park since the implementation of mass dog vaccination in 2003. But the interventions have also given us a very useful opportunity to learn about dog ecology, dog demography, which is also important in informing strategies. And if you remember one of those initial dogmas about stray dogs, it turns out from the campaigns that it's very obvious that the vast majority of dogs are accessible for parenteral injectable vaccination. If you were to wander in a village and see these dogs wandering around, you might assume that they're strays. But you can see they've all got green marks, and these were administered during a vaccination campaign. And this young man was able to bring all those dogs, handle them, and get them vaccinated quite effectively. We know that dogs of all ages can be safely vaccinated, and conventionally, puppies are not vaccinated till after about 3 months of age. But a study we did showed that young puppies, less than 3 months, mount a very effective immune response to vaccination, and that vaccination of pups is very important in these populations when you're going in just once a year, not only to achieve the vaccination coverages you need, but to sustain those also through the year. And so most dogs are owned. They can be bought for vaccination. You can see this very orderly line of very well-behaved dogs. I kind of wonder what it would be like if we tried to do that in this country. But this is very typical. I didn't make up just this one slide. And most dogs have names. As you'll see, you might be able to read this. This is a dog vaccination register. Mostly they're dominated by kind of fierce animals. So Simba is very common. That means lion, or Chewy, which means leopard. But the Tanzanian dog names are also a fantastically interesting reflection of sort of the global political landscape. They like global figures too. And you'll see here a couple of Osamas creeping into the dog register. And I did a quick analysis of the frequency of occurrence of dog names in the register. And you'll see in 2001, Osama makes a big impact. In fact, I had to plot this on 2 scales because Osamas weren't right off the roof. And then in 2003, well, Saddam comes along as a very common name after having made some appearance in the early 1990s. Bush is scattered throughout the 2000s, and in 2010, in good time, Obama comes along. And then 2 weeks ago, I was in Kenya, and I met my first Trump. Trump was actually a very friendly dog. But for some reason, and this is actually quite unusual in these communities, for some reason his owner had decided to have him castrated. But there is a serious point here. Most dogs are owned, most dogs are valued, most dogs are accessible, and this applies across Africa. These are some images from campaigns run by Mission Rabies in Malawi, which show that people are excited and enthusiastic by campaigns. They'll go to great efforts to bring their dogs, and they recognize the importance of dog vaccination in preventing human rabies deaths that had been on the rise in these communities. And even in Asia, where there are more street dogs, and the challenges are undoubtedly greater, but here when you have well-organized campaigns run by well-trained and well-managed teams, then it is possible to reach a 70% coverage. Again, these are images from Mission Rabies campaigns in several communities in India. And this slide perhaps gives me the greatest cause for optimism. Several years ago, I was in Sri Lanka, and all I heard then, it's impossible to control rabies. We need oral vaccines. We need to get rid of more dogs and remove more dogs and reduce dogs. It would just be too impossible. And here we can see these dark blue columns here, that the level of dog vaccination, the number of dogs vaccinated has been consistently increasing. This is with parenteral injectable vaccines. In line with that and with dog rabies coming under control, we see human rabies deaths in black really coming down to very low levels. And I don't know whether you can see, but there's some pale blue columns there. And this is really important because this represents the demand for human vaccine. And so human vaccine is also coming down. And this is very costly. And the savings that are made in that reduced demand are a really important component of the cost effectiveness of dog vaccination strategies. So let's go back to these original dogmas. I think we can confidently say that these are common misperceptions that have been hampering our efforts. Rabies in wildlife doesn't make it impossible to control or eliminate rabies in dogs. There are not too many stray dogs in Africa and Asia. And if some of those dogs are ownerless, it is still possible to vaccinate enough dogs. We need 70% of dogs, not 100%. We can vaccinate enough dogs to control dog rabies. And given the savings that we see, if we can bring human vaccine use down, even if we need to make investments in dog vaccination, these are likely to pay off in the long run. And so across a wide range of settings in Africa and Asia, mass dog vaccination is feasible, it's cost effective, and it can result in the elimination of rabies. And where are we today with our research? Well, a lot of my own work is working with colleagues to look at improving vaccination strategies. And some recent work was carried out to look at the thermotolerance of vaccine. And the study showed that existing high-quality dog rabies vaccines do already show a high degree of thermotolerance. We probably don't need new dog vaccines. They are very excellent vaccines, the ones that we have. Here you can see vaccines stored under different temperature conditions. In the green here at 25 degrees C for 3 months and 6 months, in the blue at 30 degrees for 3 months and 6 months. And the immunogenicity of these vaccines is equivalent, these vaccines, to those that are stored under the conventional 4 degrees cold chain. And this gives us new opportunities for distribution of vaccines using supply chains and networks that are already existing, but also perhaps looking more at community-directed interventions, engaging more with communities more directly. And we believe that dog vaccination, particularly community interventions, can help build what we describe as platforms of trust. Rabies interventions through these platforms of trust, we believe, can strengthen the surveillance and response capacity of what are quite fragile health systems in many parts of Africa. In the wake of the Ebola epidemic in West Africa, there were several constraints that were identified in relation to health systems. One was the lack of trust, lack of community engagement, and poor collaboration between sectors. And dog rabies vaccination can really help to strengthen all these areas and have cross-cutting benefits, not only providing benefits in terms of rabies control, but helping with that engagement and trust between health authorities and communities. And it can also contribute to several of the Sustainable Development Goal targets relating not only to human health, but also to poverty and to inequalities. So in thinking about where we go from here for Africa and Asia, we can look to Latin America and see from the experiences they've had the direction that we might be taking. Latin America is now very close to eliminating canine rabies. You can see just a few pockets of the disease in red. Human deaths from dog-mediated rabies occur now in only 7 of the 35 countries in Latin America. And key factors underpinning the success are intersectoral collaboration, good collaboration between medical and veterinary communities. In Latin America, this was spearheaded by the medical side from the Pan-American Health Organization. And this has been a really important factor in driving the success. They've been very successful in cross-border coordination, which is really important for large-scale and regional elimination. And very importantly, they've made investments in dog vaccination. These are not very high, only 20% of the total cost of rabies prevention. Still, most of the expenditure goes towards human vaccine and PEP. But that has been sufficient to vaccinate 60 to 70% of dogs and to get to the situation where we are today. When we look at expenditure in Asia, it's rather different. It's not true to say that rabies is being neglected in Asia. It's not. Health authorities are putting quite a lot of money into control and prevention, but directed at human vaccination only. And this is failing to reach the poorest. Those people are falling through the gaps in the health sector and health system. And this is why we're still seeing quite a high incidence of human deaths. Remember, 37,000 deaths in Asia, despite these high levels of expenditure on human vaccine. But very little investment in dog vaccination. So we strongly advocate for increasing levels of dog vaccination coverage to really create that safety net. dog vaccination will protect rich and poor alike. You don't have to rely on your ability to get to a health clinic to get that vaccine to save your life or your child's life. And when we look at the trajectories from Latin America, we can also see how effective this can be. Here, figures from a stylized version of events in a Latin American country where rabies was endemic. Dog vaccination implemented here in the dotted line quite rapidly, bringing dog rabies under control in the grey shading here. Human rabies deaths following that decline. And really within quite a short space of time, reaching a point where you have 0 human deaths from dog-mediated rabies. The next step, eliminating canine rabies entirely, is going to be more challenging, disrupting transmission and maintaining freedom from disease. We know that there are problems of incursions into areas when they've been declared free of rabies. And so we need to sustain our efforts, we need continued investments, and we need very good surveillance. But we have very good tools, again, at our disposal for surveillance. Using sort of whole genome sequencing now is a very powerful approach that allows us to identify very precisely the source of new outbreaks. And during the Ebola epidemic, again, there are techniques developed, a lab in a suitcase technique, that meant that you were able to get from a sample to a whole genome sequence within a few hours. And this has been recently applied in Tanzania by my colleague Kirsten Brunker. And she was able to get from a dog rabies case in the Serengeti to a whole genome sequence within a few hours. And that can tell you exactly where that virus then is originating. And she was able to do this, not in a fancy lab, but in a very simple, basic district veterinary office on the edge of the Serengeti National Park. So we have great partnerships, we have great tools. Partnerships are being led by the tripartite organizations of the World Health Organization, the World Animal Health Organization, the Food and Agriculture Organization of the United Nations, along with the Global Alliance for Rabies Control, which has been spearheading, as we heard, the World Rabies Day campaigns, as well as the Partners for Rabies Prevention initiative. And this has been a very powerful partnership, and it's partnerships that we're going to need going forward. And in 2015, this partnership agreed a target of 0 human deaths from dog-mediated rabies by 2030. So we have a target. The clock is ticking. We don't have much time, and we really have to make huge efforts now to move towards reaching these targets. So can we make rabies history? More than 100 years ago, Louis Pasteur said that to solve the problem of rabies would be a blessing for humanity. Well, we have the evidence, the tools, the partnerships, the strategies to eliminate human and canine rabies. There can really be no reason, no further excuse for tolerating the tragedy of human rabies deaths. The time is now, it really can be done. So just in finishing this talk, I'd like to briefly acknowledge that the work of a large number of people in the rabies research teams that I've worked with from the University of Glasgow, Tanzanian institutions, institutions from other parts of the world. And also to provide recognition that this is work that's been funded by a lot of different donor agencies that come from many different sectors: human health, animal health, international development, as well as wildlife conservation. We need these partnerships across all sectors to tackle this terrible disease. And finally, I just want to say that I think we can all make this a world where our association with domestic dogs, our oldest companion, is not tainted by the horror of rabies. So let's make rabies history. Thank you very much.
Well, thank you, Sarah, for a wonderful lecture on a hugely important topic. A wonderful and lucid lecture. We've now time for questions. So who would like to start? Let me get over here. Yes, question there.
Yes, I'm very...
Just wait until you get the microphone.
Thank you. Fascinating. Is it on? Is it on?
Yeah.
Yes, it is. A fascinating lecture. I'm very ignorant about the actual disease. Is it like smallpox, where when all rabies is eliminated in animals and humans, that it just dies and ceases to exist? It disappears from the earth?
Well, we're quite careful when we're talking about elimination versus eradication. So smallpox has been eradicated. It has been eradicated from the earth. We can't say that about rabies because there is still circulation of the rabies virus in bat species, for example, and we don't yet have the tools to eliminate it entirely, although there is progress being made on that. So what we're talking about is elimination of canine rabies, rabies mediated by dogs, in the cycle sustained by dogs. And those are the vast majority, are the cause of the vast majority of human deaths. So we're very confident about talking about 0 human deaths from rabies, so elimination of human deaths from rabies. It will take longer to eliminate canine rabies overall, and it may be some way off before we can talk about eradicating rabies. But the first target, I think, is an important one, and we shouldn't be put off by the fact that we can't yet get to the point of eradication.
Yes?
Thank you. Would you mind giving us a bit more information about likely cost of getting us to that first target? You helpfully pointed out the benefits of inoculation against the cost of dealing with the disease, but what about the overall cost?
So the cost of vaccinating dogs can be broken down into several components. The vaccine cost itself is a fairly small component of that. There's obviously costs of other consumables, transport, and staff costs involved. But we think that it's quite hard to come up with precise estimates. In fact, for all global elimination programs, the economic costing can be quite difficult. And we're quite realistic in the rabies community about not saying we need to go and get external funding for everything. There's quite a lot of components of those costs that can already be covered by national veterinary services and other providers in country. But I think a really critical constraint that we face at the moment is one around procurement and availability and reliable supply of good quality vaccine. This is a challenge that many countries face. And if we can make investments and find ways of getting that vaccine to these countries, I think we're going to go a long way towards getting countries started on their national plans and implementing those. And those costs don't need to be high. We also need to provide some support for sort of chaperoning technical support for countries to build the technical expertise. This is not a highly technical intervention, but there's still not a lot of confidence that it can be done. And so once countries start working on rabies, it's very commonly I hear, oh, it's much easier than we thought it was going to be. And the dogs are actually much more accessible than we thought. So if we're looking at Africa, for example, I reckon that I'm reluctant to give too precise figures, particularly with colleagues here from the pharmaceutical industry. But I reckon that over 5 years, $100 million would cover the cost of procurement of vaccine for most countries in Africa to vaccinate sufficient numbers of dogs. And in the great scale of things, we talked about $1.7 billion per year on human vaccine. That's not a huge investment. And by having that reliable supply of vaccine, I think would be a very important catalyst, as I say, for taking us forward.
Thank you. I think there was a question there. And then we'll take the ones further forward.
Thanks for a nice lecture. Is there an asymptomatic carrier state in bats? And do bats bite dogs on occasions?
So there's quite a lot of debate about the asymptomatic carrier status. But bats, it hasn't been proven that there's an asymptomatic carrier status, and bats, when they get rabies, do develop symptoms. And yes, bats can bite dogs, and there is a possibility of spillover transmission from bats to dogs, and there is a potential for new cycles to be set up. That's something that we have to be clear about, and we have to sustain surveillance. If we've achieved freedom from dog rabies, we need to implement those good levels of surveillance. But we do have time with rabies. It's not like if there's a spillover event. It's actually quite unusual for that new outbreak to then be sustained. And if it is sustained, we have time to respond to it. It's not an explosive epidemic like we see with smallpox or SARS. And if our surveillance is good, we should be able to respond to that and act on it. But again, it's the reason why we don't talk about eradication, but it's a manageable problem.
From the human side of things, where does rabies sit in the neglected diseases burden of the world diseases?
So it's arguably one of the most important zoonoses. It is a disease that's prioritised within the WHO neglected tropical diseases. It's recognised as a high priority. And I think it's a combination of things. We quite often just focus on the burden of disease, and we rank diseases according to their burden. And you can get some, rather distasteful sort of competitions about my disease is more important than your disease. But I think it's really important also to consider how feasible it is and how cost-effective it is to deal with it. Rabies is dog vaccination is a highly cost-effective intervention. It's a low-hanging fruit. It's something that we really shouldn't be living with. And as I say, I don't think there can be any excuses for living with it. But it is recognised as a priority by the World Health Organization, by the World Animal Health Organization. And it ranks pretty highly when we're talking about neglected diseases and zoonotic infections. Perhaps just one more comment that actually, if we look at the number of cases from zoonoses worldwide, and I talked about the 59,000 human deaths, this actually contrasts quite starkly with some of the diseases that we invest a huge amount more in, like SARS or highly pathogenic avian influenza, that kill actually hundreds of people. Now, of course, we're very concerned about those diseases because of their pandemic potential. But I think we mustn't forget the fact that rabies is killing this number of people year in, year out. And it's really a huge burden that is almost invisible to most of us.
Question at the back.
Sarah, Stuart Reid, Royal Veterinary College. Sarah, outstanding as ever, and thank you. I used to be an epidemiologist, and thank you for making your science so accessible to us here. I don't think you made mention of the term One Health anywhere in your presentation. If you did, I missed it, so I apologise. This seems to me to be one of the most remarkable One Health stories there is. But if you look at the paradigm that the FAO talk about, they talk about the technical level, they talk about the behavioural level, they talk about the institutional level, and all these need to come together for there to be a One Health solution in this case. So where is the failing taking place? It seems to me we have the technical level. Is it about behaviours, or is it about institutional commitment, and is it a uniform in terms of failing across the planet?
So I think there are a number of elements to that question. I think One Health sounds completely logical and feasible in practice, in principle. Of course, we should all be collaborating across sectors. But I see those institutional barriers as still being quite high. It can be very difficult, for example, with rabies, when we talk about the cost savings from the human health sector and then the costs in the veterinary sector. It's actually very difficult to work in terms of distributing where those budgets are. And actually managing the disease across those different sectors because of those institutional structures. There are also inevitably always questions about sort of ownership, sort of who's in charge, and these are very difficult challenges to face with One Health. In many cases, it's considered that sort of vets are trying to get onto the bandwagon and making their profession sound more important by engaging in One Health. And I think we fundamentally disagree with that there are really important reasons why we should be working together. But we shouldn't ignore the challenges, and I can't give you an easy answer as to how to make it work. But I think it'd be worth quoting Bernard Vallard, who was the former director of the OIE, because he said, if we can't make One Health work for rabies, we can't make it work for any disease. It's so apparently obvious that we have to do this, but still there are barriers. It's still difficult to get people cooperating across sectors, not through any malice or antagonism, but just because of the way these institutions function. And I think we see actually a lot of leadership from Africa. So several African countries have established zoonotic disease units, which are inter-ministerial. And in Kenya, for example, they have a rotating chair from the Ministry of Health, from the Ministry of the Environment, from the veterinary services. And so they're trying to have a much more sort of egalitarian approach to leadership and ownership of these issues. And they're also making excellent progress with their national campaigns. And so I think that's one approach that I think can be very successful. But it's about people. It's about people and politics.
Yes, another one at the back.
I'm just curious how obvious it is to the people in the villages about the benefits of the campaign that you're. I mean, are they really conscious of the fact the number of deaths is going down? Does it affect their day-to-day life? Because if they were really clamoring out for this vaccination program to continue, surely you'd be in a much better position.
So it's an interesting question, and I wish I could have somebody here from those communities to tell you directly. But the impression we get very strongly is that they're very much recognised. The benefits are very much recognised. People can see fewer rabid dogs. I think because rabies deaths are just the tip of the iceberg in terms of problems, what people see, they don't see rabid dogs. They don't see people getting bitten and being terrified because what can they do now? And having to have this months of anxiety and uncertainty waiting to know what the outcome is going to be. So they know that. In some cases, people in communities are saying they're now keeping dogs because they're not worried about rabies anymore. They come. That's one of the main signs. They come year in, year out when we're doing these campaigns. And they wouldn't come if they didn't recognise that there was a value to it. So yes, their voices need to be heard. And I think that what World Rabies Day campaigns do is allow us around the world, it'd be great if you could get onto the website to see this, it's a chance for communities to have their voices heard, that they want something done about rabies. But these are not the most influential people in the country. These are not the ministers, these are not the directors of veterinary services families that are being affected. As I say, these are people in disadvantaged communities, so we need to give them that voice. But if that can come from sort of a groundswell of demand, politicians would react. I can't think of any other disease that in the lifetime of a serving politician, say a director of veterinary services, that you can make such an impact on every single person in your country, because the bite rates from rabid dogs is phenomenally high, sometimes 100 to 200 people per 100,000. So everybody knows somebody who's been bitten by a rabid dog, and it could have an impact. So I'm curious about why there's not more higher political will. If anyone's got any insights, I'd be really keen to hear about it. But we need to help people who are being affected to get their voices heard.
So you haven't had problems with community engagement, it's more engagement with the communities, with the politicians?
I think that it's often at the national level. Of course, when you do a prioritisation exercise, it's been happening quite frequently across Africa. Rabies comes at the top of those zoonoses. It's a disease everybody knows about, knows that we should be doing something about. But when it comes to that actual political commitment to invest people, resources, and we're not necessarily talking about money, it's about getting organised, having a commitment to get on and tackle the problem, then we seem to have some problems. So I think it's not the problem of the communities. You get vaccine into these communities, the dogs will get vaccinated.
2 more questions, and I think we probably should. Perhaps we'll make it 3 more questions.
Thank you. Well, just a brief comment, if I may. I'm a vet like Sarah, and a great talk, Sarah, and like Stuart. Perhaps if our politicians realised that we had rabies endemic in Britain, and one of the earliest lessons I learned as a veterinary student was that we eliminated it by muzzling dogs. We didn't even have vaccines, we didn't know about genomes. but we knew if you stop dogs biting people, you get rid of rabies. Seminal lesson from history from the UK.
Yep, and thank you also for pointing out the fact that we have endemic rabies in Britain as well. And it's a different virus, the rabies virus. It's a European bat lyssavirus, but it causes the disease rabies and it circulates in bats. So it is a disease that we need to be aware of here as well. But it's also a problem for the UK because we actually spent an awful lot of money on post-exposure vaccination of people who've been travelling to countries who are then bitten by rabid dogs and have to have an emergency evacuation, come back to the UK to get that post-exposure vaccination. So it's not just a cost to developing countries, it's a big cost to us as well. And that's another area where I think we can try to engage with politicians in this country. But you're absolutely right that rabies is an easy disease to control. I think the vaccines now make that a more feasible approach than thinking about muzzling all the dogs. But the principle is the same. It's hovering there with its R naught just over 1. We should be able to get rid of it. And I hope that in my lifetime, in the lifetime of these children, that they don't have to see this disease anymore.
I think there was a question here. Yes, and then a final one.
Thank you.
Just behind.
Does rabies affect cats? And do cats bite people who've got rabies? Sorry, the cats who've got rabies, they bite people.
Yes, yes, rabies affects cats. It affects all mammals, potentially. And yes, cats with rabies bite people. And it can be quite, it's certainly a high risk if a rabid cat bites a person. But the difference, and the reason why we're concentrating on dogs, is that cats can't sustain cycles of rabies independently. They're not the reservoirs, the maintenance of the rabies virus. And if we get rid of rabies in dogs, it will disappear in cats. So we do ask people to bring cats. I didn't show you too many pictures, but they come in sacks and we can, slung over the shoulder. But it's fortunate, really, because dogs are much easier to vaccinate than cats. So I'm quite relieved that... and there's nowhere in the world where we think that cats are reservoirs, which is also good news.
I think we've got a final question here. Maybe I'll run to one more.
Yes. My main question is, my sister lives in Luxembourg, and I mean, in your maps of the world, it showed that Western Europe, until a very precise border, was rabies-free. But I mean, certainly in the 1970s and 80s, they'd fairly often have a rabid fox coming in because they couldn't hunt, and they'd come in and try and get the chickens, and they would catch them. They probably couldn't eat them. So that's one question. Secondly, do they require a booster? These vaccinations, or is it done for life, as you might say?
So regarding Western Europe, and thanks for raising that, because I didn't have time to talk about fox rabies in Western Europe. But yes, there has been rabies in Western Europe. In the past, it was a problem with dog-maintained rabies, and then it shifted around the Second World War to fox-maintained rabies, and the fox variant of the virus. But that demonstrates the success in controlling rabies in Europe really demonstrates the principle of reservoirs. So in Western Europe, fox rabies has been controlled by mass oral vaccination of foxes. And that showed that when you can control rabies in foxes, rabies then disappears in all other species. We've eliminated the rabies virus in Europe as a result of that. The second question was, sorry? Oh, boosters, thank you.
Yeah.
Boosters, yes. So the rabies vaccine is a very effective vaccine, an efficacious vaccine. And we think a single dose depends on the vaccine, but the high-quality vaccines should last around 3 years. Now, the life expectancy of these dogs is actually only about 2 years. They have a very high, rapid turnover. Pups are born very fast, which is why we need to vaccinate pups, but dogs also die. And so, on average, it's one sort of shot per lifetime of a dog. But yes, we do boost dogs. So if we're going back and running annual campaigns, we wouldn't say don't bring your dog. It's logistically complicated to do that and cumbersome. And it certainly won't do any harm for them to have a booster.
Very final question.
Is there any Is there any evidence of disease reduction, either in infectious or otherwise, animals or humans, as a result of the capacity building and the surveillance that's done for rabies? side effects?
Yeah, no, that's an
as it
interesting
were?
question, and that hasn't been looked at, and it's probably still quite early days to look at that, but we are really interested in these cross-cutting capacities. And we often talk about implementing and designing a specific surveillance system for avian influenza, for example. And actually that's something that really worries us, and quite rightly so. But it's not actually something that worries these people. And one of the problems that we see is engaging communities and building their trust. And we can do that by tackling problems that are concern to them. Now, rabies isn't their biggest disease problem. I'm not trying to claim it is, but it's something that we can actually do something about, and not all diseases we can do something about. And as I said before, the benefits are visible and they're appreciable. And so we see that this community engagement, with rabies, we're working across human and animal health. That's a really important issue, as we talked about in One Health, in tackling many of these other zoonotic diseases. So I'm very interested to look to see whether and how we can measure that sort of added value in terms of rabies vaccination. But I think it's a really important principle that if we're going to engage with global surveillance for diseases that are of, well, global concern to all of us, we have to engage with people in these communities. And these are the people that matter. And one way of doing that very effectively, it's not the only way, but one way would be through control of rabies.
Well, I'm sure the questions and discussion could continue, but I think we better bring proceedings to a close. And my final, very pleasant duty, Sarah, is to award you with the medal. So may I award you with the 2018 Leeuwenhoek Medal and Prize for your pioneering work towards the eradication of rabies. Many congratulations.